Hello everyone, my name is Oro Pacheco.
And my name is Helen Choma.
I'm Jason Hoyt.
And I'm Linda Shi, and we are presenting to you an overview of the CaveCamX project.
Imagine if you could experience a place that you've never been to without actually going there. We can do this now with technology known as a Cave Automatic Virtual Environment, or a cave. This is basically a room filled with 3D projectors, which allows users to be immersed in a 3D model. We can generate content for a cave with tools such as a CaveCamX. The CaveCamX is intended to be an integrated platform that can automatically document a scene in such a way that can easily be displayed on a cave.
So you might wonder why we're doing a new iteration of the CaveCam project. Well, our CaveCamX project aims to solve one of the pitfalls that all projects have. And all the pitfalls are written down in this whiteboard. So for example, we're planning to create a new web interface so that it's easier to configure the settings of the camera. Secondly, we aim to have camera notifications so that you can know when the pictures are currently taken and when the panoramas are done. Thirdly, we plan to put a telemetry management system into the project so that it can talk to the real-time control code. And the reason why we want to do that is because we want to know exactly the timing between the pictures so that the transition from picture to picture are correct. And lastly, and more importantly, is to provide full control over the gimbal movement and the panorama orientation generator. And the reason why we're trying to do that is because by providing full usability of the gimbal, we can make sure that the system is fast and also it's camera independent so that you can use any camera that you want to create panoramas by only changing the mounting of the gimbal on the CaveCamX project.
Building a web-based interface to make camera configurations and using it to take pictures remotely creates for a more user-friendly interface. On the left, the Python server serves as a bridge between the web interface and the student QX1 cameras. On the right, the web-based interface has features such as focus, which allows users to set the focus manually. It allows users to adjust settings such as aperture, shutter speed, and ISO, and on top of that, it gives them the feature to take a picture.
As you can see in this demo, we have notification messages that appear on the web interface. Those messages update whenever a picture is taken to notify the user about the camera usage and whether the camera is being used manually. There is also the picture URL update section, which updates while the camera is taking pictures, showing each picture URL.
Users have the option to view pictures on the SD card without needing to take the SD card out of the camera. If they wish, they can load full resolution images of the camera and review them. And this creates a more user-friendly interface for taking panoramic pictures for the CaveCamX.
The Telemetry Manager is a key component of the CaveCamX project. The Telemetry Manager enables the CaveCamX to aggregate all sensor data from both discrete sensors and the image sensors. To do this, each sensor is constantly checked by a sensor server, which updates the computer with the most recent sensor value. When the CaveCamX takes a picture, the real-time control code will use the QData handle to make a snapshot of the current sensor values and enqueue the data for writing. The Telemetry Manager then writes the data to a file in a separate thread, ensuring that disk speeds do not affect the performance of the CaveCamX. I will now show you a simulation of what the Telemetry Manager does when it is running. The bottom window will display the contents of the output file. I will now run the Telemetry Manager for 30 seconds, taking one simulated picture each second. In the output file, we have the distance from the CaveCamX to the object in frame in meters, then the pan and tilt angles in degrees, and then the millisecond timestamp of each entry, and finally the file name associated with this entry. This information is necessary to enable quick and accurate stitching of images from the CaveCamX.
Assuming that the user has entered the correct values into the algorithm, the gimbal is going to start moving to locations in space in order to generate a panorama.
The way this works is that the panorama orientation generator is going to start by asking the user some information about the cameras. The user needs to enter the sensor sizes along with the focal length of the camera that he or she desires, along with the overlap for the pictures. By specifying the correct vertical and horizontal overlap for each of the pictures, then the algorithm will generate or spit out locations in space where the Game Boy is going to move in order to generate the panorama that's desired.